Hi, so welcome to today's video lesson. And in today's video lesson, we're going to be looking at the sum of terms in GP, in geometric progression. So there are two formulas to actually finding the sum of terms in GP. Now, when the common ratio is greater than 1, so when the common ratio is greater than 1, we use this formula. Sn equals A Rn minus 1 over R minus 1. So this is when R is greater than 1. So when R is less than 1, so this is what we use. Sn equals A 1 minus Rn over 1 minus R. So what's the difference? It's just this position that just changed. R goes here and 1 comes here. R goes here and 1 comes here. So that's the difference between the both of them. So they are very similar. Alright, just that 1 is used when R is greater than 1 and when R is less than 1. So you have to ask that question before you start solving that. Is R less than 1 or R is greater than 1 before you decide on which formula to use. Alright, let's see an example. Alright, so let's say that the sum, that's S9, okay, let's say that we have to find S9. Yes, we have to find S9. The sequence is actually 4, 20, 100, 500, and so on. So how do you find S9? Now this is a geometric progression. How do I know? Because look at it. The difference is clear. 4, 20, 100, 500 is not a difference. It's a ratio. So it's a constant multiple. So you have R then has to be 20 divided by 4, and so that's 5. So that means 5 times 4 times 5 will give us 20, 20 times 5 will give us 100, 100 times 5 will give us 500. So the common ratio is actually 5. So R equals to 5 and A equals to 4, first term. Now the question now you have to find Sn. So now which formula should you use? Now check is R greater than 1 or less than 1? Yes, R is greater than 1. It's 5. R is 5. So we're going to go and use which formula? This formula. Okay, good. So then we are saying that Sn equals to A into bracket R n minus 1 over R minus 1. Okay, and that gives us S9. S sub 9 equals to, what's our first term? First term is 4. That's 4 into, what's our common ratio? 5 raised to the power of n. 9. 5 raised to the power of 9. Let me write that properly. 5 raised to the power of 9 minus 1 over 5 minus 1. And that gives us 4. What's 5 raised to the power of 9? 5 raised to the power of 9 is large. That's about 1953125 minus 1 all divided by 4. So 4 cancels out 4 here. And so S9 is equals to, so this minus this, so this minus this. And so we have 1953124. So this is it. How do I pronounce this in words? That's 1,953,124. So that is the sum of the ninth term. Alright, so let's take another example. So let's say that the third term of a GP is actually 63. The fifth term is actually 567. So let's calculate S7. All right. Now, just like we did in the AP start, in the AP section. So you have Tn equals to AR raised to the power of n minus 1. Okay, so that means that T3 would have to be AR 3 minus 1 equals to what? 63. And so AR squared equals to 63. Okay. Then what about T5? So T5 will then be AR5 minus 1, and that equals to what? 567. 567. And then AR raised to the power 5 minus 1, you have 4 equals to 567. Okay. Second equation. So can we solve the first and the second equation simultaneously to find out A and R? AR squared equals to 63. Then you have AR4 equals to 567. All right, so let's quickly do that. Then let's divide these two equations since we're dealing with ratio. So A can cancel A, and so I have R squared over R4, and that's equals to 63 over 567. Well, from the laws of indices, I know that this is going to be R squared minus 4. From the law of indices, just take that. And so 63 divided by, so this is 63 year 1, 63 year 9. So that's 1 over 9. Okay, so that means that R is equal to 2 minus, that's minus squared equals to 9 minus 1. Let's do that. Okay, so I can write this as 1 over R squared, right? From law of indices equals to 1 over 9. So since this numerator and this numerator is the same, I can basically just say R squared equals to 9. And if I take the square roots of both sides, so R equals to 3. And if R is equals to 3, I can put that into this equation, right? And so R squared equals to 63. To find my A, I can say that 3 squared equals to 69, 63 equals to 63. And that's A times 9, because 3 squared is 9 equals to 63. And so divide this out by 9, what do you have? So you have A equals 63 divided by 9, you have 7. So therefore your A is equals to 9, and your R, where's your R? Okay, I got my R to be 3. So that's it. My R equals 3 and my A equals 7. Okay, so now we are asked to find what exactly, or that we are asked to find S7. So can we go ahead to find S7? Now the first question to find S7 is to ask, is R greater than 1 or less than 1? R is greater than 1. So that we're going to use this for particular formula. This one. Because R is greater than 1. Okay, so A is equals to 7 and R equals to 3, as we have looked at earlier. So we have to find what? S7. Okay, remember that R is greater than 1, so That means that we're going to use the formula a into r n raised to r raised to the power n, r raised to the power of n minus 1 over r minus 1. So that s sub 7 equals a is 7, r is 3, n is 7. 7 minus 1 over 7 minus 1. Okay, so that is 7 into 3 raised to the power 7 is actually 2187 minus 1 divided by um okay, I think I missed this place. R is actually 3, sorry. R is 3 here. So that's 3 minus 1, that's 2. Good. So S sub 7 is equals to 7 into this minus this, what you get? Just minus 1, that's 2186, 2186 divided by 2. I think 2 here can go here, 1, 2 can go here, 1993. Yes, yes. So that's 7 multiplied by 1093. And so S sub 7 equals 7 times that. That gives us 7,651. So this is the answer to the question that you are given. All right, so this is how to solve questions on sum of terms of a geometric progression. All right, so if you found this video helpful, kindly click the like button and comment thank you on the comment section, then share the video to as many people that you think might be in need of this video. All right, thank you, bye.